And lastly, what we're going to do is look at how we can do those series with an arithmetic sequence. We looked at some series in the previous section, and where we had to just add up all the terms. With some of these, though, there's a pattern even to what you get when you add things up, and so it's nice if we can find that pattern. So if I'm adding up 20 terms, I don't have to find all 20 and add them all up. And so here I'm just going to write an arithmetic sequence, and like a specific arithmetic sequence. I'm just making one up real quick. So we'll say 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25. Okay, so here we're adding up. You can see that each term goes up by 2 each time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm adding up these 11 terms. We'll go ahead and do one more, just for the initial show of this. So 12 terms. And then I'll backtrack to that 11 again, just to show another piece. But we'll start with an even number. With arithmetic series, we can add up all 12 of these numbers one at a time, but there's a pattern to these. If you take the first number and the last number and add them up, in this case you get 32. Then, if you take the second number and the second to last number, 25 and 7, you get 32. Here we would get 9 and 23 is 32. 11 and 21 is also 32. 13 and 19 is 32. Want to take a guess at what 15 plus 17 is? 32. This works with all arithmetic sequences. If you take the first number and the last number and add them together, that would tell you what every pair of this process would be. So then what that means is we could do this. I could add up all these numbers, or what I could do is I could add up the first and the last number, because I could just pair these up and every pair would add up to that same number. The other thing we would need to know is how many pairs we have. So here we can count 1, 2, 3, 4, 5, 6. I have 6 pairs, but we don't even need to actually physically pair them up, because if you know you have 12 terms in the sequence, your number of pairs is going to be that number divided by 2. So here is our formula. The number of terms divided by 2 times the first term plus the last term. So here I have 6 pairs of 32. I could take 6 times 32 and that would tell me what these add up to. Now I will backtrack for a second, and I purposely started with an even number of terms just to kind of show that pairing, but I do want to show you that even if you don't have an even number, it still works out. That formula still works, because here I get 30, here I get 30, here I get, that's 30, that's 30, that's 30, that's 30, That's 30. So what you'll see is that when there's an odd number, obviously you can't pair everything up. But what you'll also notice is if you try, the one left over will always be exactly half of what the pairs add up to. And then if you think about that in the context of that formula again, now I have 11 numbers. So 11 divided by 2 is 5.5. So here what I have is I have 5.5 pairs of 30. 5 plus 25. So I have 5 pairs of 30 plus an extra half a pair. What's half of 30? 15. So even with an odd number of terms, that formula still works to find your sum. So let's go ahead and use that formula a little bit. Okay, so here we want to find the sum of the first n terms of this arithmetic series. And again, the word series is just the word meaning you have a sequence and you're adding up all the numbers. So here I've got -2 plus 3 plus 8 plus 5 or plus 13 plus 18 plus la da 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 da, following that pattern all the way up to 15 terms. Okay, so you can recognize, first of all, it says it's an arithmetic sequence, but even if arithmetic series, but even without that, you can recognize that because to go from -2 to 3, it's up 5. 3 to 8 is up 5. 8 to 13 is up 5. 13 to 18 is up 5. So we're going up by 5 each time. So it's an arithmetic sequence. And so we use the notation S sub 15. What this means is the sum, that's what the S stands for, of the first 15 terms. So I'm adding up how many terms? 15. So that means I'm going to have 15 divided by 2 pairs. And each pair is going to add up to the same thing you get if you take the first number plus the last number. Now, I do want to point out that in this particular example, we don't know the last number. It was written up to 5 terms, but I'm going up to 15 terms. You can see that dot, dot, dot. I didn't have all of them written. So I'm going to have to figure out what that 15th term is before I can actually find this sum. Fortunately, we know how to find the 15th term. We simply have to take the first term and add that common difference, which is 5, 14 times. So 5 times 14 is 70. 70 plus -2 is 68. So now we know the 15th term. Now we can find the sum of the first 15 terms. So 15 divided by 2 is 7.5. -2 plus 68 is 66. So now we just need to take 75. Sorry, trying to get my calculator out. 75 or 7.5 times 66. And we get 495. All right. Last set of examples here. Here we've got some written in summation notation. So we don't have the list of numbers. We are told that these are arithmetic series, but we're not always told that. And before we can use that formula, we have to know for certain that it's an arithmetic sequence. That the sequence that we're adding up, again, that's what a series is it's adding up the terms in a sequence. But before we can apply that shortcut formula that applies only to arithmetic sequences, we have to make sure that this is in fact an arithmetic sequence. Okay? And there's one of two ways that you can do it. First of all, I will point out that arithmetic sequences, if you remember what that formula looked like when we found the explicit rule, it was a linear function. And if we think about what a linear function is, it goes up by the same amount each time, we can be confident in saying that if the explicit rule is a linear function, then that sequence must be arithmetic. So you can see both of these examples. That's a linear function and that's a linear function. Here's a linear function, here's a linear function. So we can say with confidence that those are both arithmetic sequences. If you're still not certain about that, that's okay. You do want to make sure that you are certain about the type of sequence it is before you apply your shortcuts. So if just looking at the formula isn't enough for you to be confident in saying that it's arithmetic, go ahead and write out the first few numbers. So we already talked about how this notation works. So we're starting when n is 1 up to when n is 10. So that's 2 times 1 minus 1. So 2 times 1 is 2, minus 1 is 1. Then go to 2. 2 times 2 is 4. 4 minus 1 is 3. 2 times 3 is 6. 6 minus 1 is 5. Then we're on to number 4. 2 times 4 is 8. 8 minus 1 is 7. And we do need, if you're writing these out to make sure that it's an arithmetic sequence, you do want at least 3 to 4 terms. You can see 1, then 3 goes up by 2, then to 5 goes up by 2, up to 7 goes up by 2. So now we can see, if we weren't confident before, just by looking at the equation, the formula, that this was arithmetic, we can now look at this with confidence and say, this is arithmetic. So now we can stop writing out all of them and just go straight to our formula, which says the number of terms divided by 2. So to go from the first term to the 10th term, that's going to be 10 terms total. And then we take the first term, which is 1, plus the last term, the 10th term. Now, fortunately, we have this formula for our sequence, so we can just go straight to finding the 10th term. 2 times 10 is 20, minus 1 is 19. So here we have 5 times 20 gives us 100. All right, now we've got this one. Again, if you're not confident that it's arithmetic by looking at the formula, go ahead and write out the first numbers. Once you write out the first few, you'll find out, yep, this one is also arithmetic. So I've got 25 terms, and I'm going to pair them up, so 25 divided by 2. And I'm going to find the first term and add it to the last term. So the first term would be when n is 1. That's 10. The last term would be when n is 25, so that's 75. 3 times 25 is 75. 75 plus 7 is 82. All right, and we have 12.5 times 92. And we can get our calculators. And we get 1,150. And that is it for arithmetic sequences.